So this section, we're going to be talking about some sensitivity analysis. Um, and so, as usual, in our linear program, we have several things we consider. So first, a change to a cost of a non-basic variable, and then a change to a cost for basic variable. And then we'll need to change the supply and demand pair. And so that could be for a non-basic variable, or that could result in a change to a non-basic variable or a basic variable. And so the two things are going to be a little bit different. So let's try just changing cost to a non-basic variable first. So um, let's say that Cij changes to Cij plus delta, and then that's if it's a non-basic variable, Ui and Vj are going to be fixed, right? And so that's going to localize our change a bit. So then the only change is to row 0 in cell ij. Those are the numbers in parentheses that we were computing. Um, and so in the row 0, right, we were computing Cij plus or minus Ui plus Vj. And in the case that we change Cij, we just add the delta here. And so that's going to be straightforward because this is the old value that was in parentheses, and so we're just going to be adding delta to it. Okay, so let's do an example. Which one should we change? How about the 1, 1 position? So if this is 8 plus delta, then what does that do to our tableau in general? That's going to just change this value, right? Because this is the value 8 plus delta minus 6 is going to be 2 plus delta. That's the only thing that needs to remain. And so in order for us to stay, in order for the current basis to remain optimal, we require that row 0 stay positive. And so 2 plus delta then must be greater than 0. And so therefore the current basis is optimal as long as delta is bigger than minus 2. Good. So that was straightforward. This is again for a cost corresponding to a non-basic variable. So really all that happens is the plus delta gets shifted down. Good. Okay, let's try a basic variable now. Oh, I guess we're going to try one more first. 16 plus delta. Remember what's going to happen? We're just going to be shifting the delta down. So 16 plus delta minus 13 is going to give me 3 plus delta. So therefore, my current basis remains optimal as long as 3 plus delta is greater than 0, or delta is bigger than negative 3. Very good. Okay, so changing a basic variable now, that can change quite a bit, right? Because the basic variables are where the Ui and Vj were defined. And so we may have to recompute a bunch of them. So that could result in a lot of row 0 changes. Let's see how that works. So here's my basic variable that I'm changing. Now, which of the Ui and Vj need to change? U1 stays at 0, but now the V3 is going to have to change to 10 plus delta. And if V3 changes, that means that U2 must change because the sum of these, right, is this. And so therefore U2 changes to 3 minus delta. And if that changes, what else must change? Well, the sum of these two must be equal to 9, therefore I must be adding a delta up here. And now I think that is all, right? And so now we can recompute the other row 0 elements, right? So now, for example, in this position here, we will have 8 minus 6 plus delta. Okay, so that's going to be a 2 minus delta. And then we compute our other ones. Let's see which one's next. This one, so that's 12 minus 9 plus delta, right? So that gave me a 3 plus delta. And then I'm not sure what order I did these in. So this one came next. So again, that's 7 minus 5 minus delta. So that gives me 2 plus delta. And so let's finish them off here. 14 minus 12 minus delta. That's 5 minus delta. Okay. We have one more. Oop, I had to change the font to fit everything in here. Uh, the last one was this 3 minus delta. Okay, so in order to remain optimal, all of these cells must remain positive. Okay, so that takes a little bit of work to figure out, but it's not bad. Again, the easiest way to do this is just take a number line and draw the solution for each of these and take the intersection. So therefore the intersection is going to be the deltas between minus 2 and 2. Good. So let's review again. Changing the cost to a basic variable is going to change the definition of the u's and v's, and so that may spread the change all over the array. Okay, good. All right. So now, what happens if I change the supply and demand by adding a delta? So this is adding delta to the right hand side. Remember, we have to have a balanced problem, so therefore adding delta to a supply will mean that I need to also add delta to one of the demands, and it will be given to you which demand to change. However, our problem is going to change whether the demand refers to or the supply demand pair corresponds to a basic variable versus a non-basic variable. Okay, so let's see how that's going to work. So let's first off, let's choose the second demand so that cell 1, 2 corresponds to a basic variable. So I'm going to change my 20 to 20 plus delta. And so what does that do to my array? Well, you can see the only change to my array, because this is a basic variable right here, is just change that to a 10 plus delta. Okay, and so that's it. That's the only change that gets made. And so what is the corresponding change in z? The corresponding change in z is just going to be at 6 delta. We're going to be adding 6 delta to it. Okay, and so if we're increasing the supply and demand that correspond to a basic variable, the change is all localized, kind of the backwards of what we just did. Now suppose that the change corresponds to a non-basic variable. So in this example, we're thinking about this cell. Okay, so in order to get a solution here, I'm going to have to put a delta into this cell, right? But that is going to create a loop, right? And so the idea will be that we need to absorb this delta into the other parts of the loop, into the basic variables. Okay, so how is that going to work? Well, if I add delta here, I need to subtract delta there, and then I need to add delta there, and I need to subtract delta there, right? So, oh, I'm sorry. Let me rephrase that. I've just added delta to this cell, so what I actually have to do is I have to subtract delta from this cell, right, to make this 0 again, so this is not a basic variable. So if I subtract delta, I add delta, subtract delta, add delta. Okay, it's confusing to see it here. Let's see if I can make that a little bit simpler. So this is what we have, and I want to make this cell empty, so therefore I need to subtract delta, add delta, subtract delta to the remaining variables. Okay, and so that's what we're doing here, is we're making this cell go away again. So that means I have to add delta here, subtract delta there, add delta there. Good. And so that frees up this cell again, so it becomes a non-basic variable. And so these 3 cells actually change. Okay, so that's what's going to happen then with our new tableau. And so now it looks like what's the corresponding change in z? We have a plus 6 delta here, a minus 9 delta there, that's minus 3 delta, plus 5 delta here, so that's going to be a plus 2 delta, it looks like. Good. And so that's it. So this is a fairly short section. The homework is on a handout because the homework in the book isn't very, it's just one problem in the book. Okay, and that's it. So I will see you later.